Hello everyone. Today we're going to talk about a few design patterns. Let's start with the memento pattern. The memento pattern consists of three parts: the originator, the memento, and the caretaker. If we see the diagram, let me put this in side by side. Okay. If we see the diagram, the originator creates a memento containing the snapshot of the current internal state, and it uses the memento to restore its internal state. So, and the while the memento it holds the internal state of an originator. Suppose we have, let's take an example, an employee database. An employee, Mr. X, has a salary of suppose 10,000 taka. We update his salary to 15,000 taka. If we want to roll back to the previous state where Mr. X had 10,000 taka salary, then in this scenario we use the memento pattern, where the originator takes the snapshot of the 10,000 taka 10,000 taka state of in the database, and creates a memento. This memento is taken care of by the caretaker. What it says is, it is responsible for keeping the mementos, like maintaining safeguards and never operate on or examine the contents of a memento. So the originator creates a snapshot of the previous state, as in the 10,000 taka. The caretaker keeps that memento keeps that memento, kind of like a registry book, you can say, kind of like a registry book. So no so there is no operation on the previous state. If we want to roll back to we want to roll back to our previous state from the current state, we we just call on the previous memento, so that we can roll it back. Okay. Um, this is just the general form of the memento pattern. Let's take a look at another pattern. The visitor pattern. Okay. The visitor pattern. There is a visitor object which changes which changes each element by how we program it, basically. So here we can see there are four objects, four elements. This could be an array, a set, or a data structure, anything. This visitor is gonna visit every element and change its states or change its values or anything we want. Um, Suppose we have a database of employees. Suppose there are 10 employees, each have separate salaries, and we want to give a bonus to each employees. What we can do is, we will program this visitor. We'll program this visitor so that it takes. Suppose we're giving a bonus of 10% of their basic salary. We will program this to set the value of salary 10% of basic plus 10% of the basic salary plus the basic salary. So what this visitor is gonna do is, it will visit every employee element or every employee salary element, and it will change the state. The pattern should be used when we have distinct and unrelated operations to perform across a structure of objects. This is our structure of objects. This avoids adding code throughout your object structure that is better kept separate. So what we did was we just added a new code in the visitor so that we don't have to do anything here in this object structure, in this array set or whatever you like to call it. We don't have to add any extra code here. We can just code the visitor and the visitor will do its work. Pretty simple and straightforward. Let's check another pattern. Let's go with the flyweight pattern. The flyweight pattern is used when there is a need to create a large number of similar objects. The large number of objects consume a large amount of memory, and the flyweight design pattern provides a solution for reducing the load on the memory by sharing objects. Flyweight flyweight pattern is primarily used to reduce the number of objects created to decrease memory footprint and increase performance. Flyweight pattern try to reuse already existing similar kind of objects by storing them and creates new objects when no matching objects is found. So, suppose we are creating a database for students. So we need to create a large number of student objects. A school can have how many? Like 1,000 students. And if I create 1,000 students one by one, this will take a lot of time and a lot of memory. It will consume a lot of memory. So what we do is we think of an abstract, this is not an abstract class by the way, an abstract student object which doesn't have any attributes, it's like kind of like a silhouette of a student. Like a student can have a name, an ID, major, his graduation date or his admission date, which we keep in the cache memory. We keep this in the cache memory, and when we need to create an object, we just call through the cache memory. It'll give us the object. We just put in our desired values. Suppose a student name Mr. X, his ID 12345, his admission date. Suppose April 2014. His graduation date. If he's in April, this is a school database we're talking about. 10 years from now, a tentative graduation date, etc. The flyweight pattern consists of two states: in intrinsic state and extrinsic state. Intrinsic state is a state where things are constant and are stored in the memory. Suppose in this example we are creating a circle object. A, cir- a circle object a circle object is constant, but its color, number of objects we need to create is different. So we keep this in the cache. This is an intrinsic state. When we create this object, we just call through this state. Extrinsic extrinsic state. These states are things that are not constant and needs to be calculated on the fly, and therefore not stored in the memory. Like I was saying, this states as a constant. Yes, here we have four kinds of circles: red, green, blue, and black. Number of circles we need to create are different. So this is not a constant value or a constant attribute. The only constant attribute is the circle object. It will be a circle, but what kind of a circle or how many number of circles we need, we don't know yet. When we know this, suppose I'm making a green circle, 10,000 of this, we just access the green attribute and create an circle object, and we just create 10,000 of it as we need it. We don't have to make 10,000 circles at once, because it will put a lot of pressure on the memory. It will consume a lot of memory, to be exact. Let's move on to another pattern. Okay, the bridge pattern. Sorry. In the bridge pattern, there are two parts. So the first part is the abstraction, the second part is the implementation. The bridge pattern allows the abstraction and the implementation to be developed independently, and the client code can access only the abstraction part without being concerned about the implementation part. Bridge pattern separates the abstraction hierarchy and the implementation hierarchy into two different layers, so that change in one hierarchy will not affect the development or the functionality of the other hierarchy. Okay, um, here we see that there is a persistent implementation, the file system persistent implementation, and the database persistent implementation. And there we have a persistent class to save an object or delete an object. So what the bridge pattern is, that we have uh, two two parts of a system which we can enhance, or which we can enhance in any way we want, add some functionality or remove some functionality independently. Suppose we have save an object and delete an object. If we are planning to have a option like copy an object, we can add a copy option number 3 here, copy an object, without thinking anything from the persistent implementation. So what this does is that there is less modification, and less hassle, basically. And if we need to change the persistent implementation, the file system and database, suppose we are planning to add some other database, suppose we want to add a third one, which is called the database X persistent implementation. I'm just making this up, making the functionality of work, basically. So if I add a database persistent implementation, database X, the third option, I don't have to touch the code from the persistence hierarchy. So this basically I forgot what is it called. Uh, oh yes, the open close principle. This basically follows the open close principle for software development. Open for modification, close for editing. Is it closed for editing? I don't know, I forgot, sorry. So whatever, the thing is that this will simply this will just keep our system in two parts, so that we can develop two parts independently, the two hierarchies independently, without touching the without touching the code without touching the code of the other one while we change one of them. uh, I think this is basically it. I just covered 4 design patterns. Um, Thank you.